Yeah. If there is any code, I mean, generally, yeah, if you try something like Great Expectations, then I think there will be some artifacts that you need to process, right?
So we have a data sets that will be analyzing through that tool.
Yeah.
That is what this means.
Yeah. You don't have to submit the data set itself, but you should submit all the other artifacts that you kind of used or tried or something, right? Yeah. Any other question? I mean, if not, there'll be, if you spun up something like, for example, for annotation, there's a tool called CVAT. I don't know if it's in the included list or excluded list, but CVAT is a tool to annotate objects or annotate images. Spinning up CVAT and actually starting it locally is a non-trivial thing. I mean, as long as you know Docker, you can probably do it. So that would, you could say, okay, I use a CVAT repository. Here's a Docker file that was used to spin it up, for example, right? Or you can also have screenshots of the tools. If the tool is something visual, then you can screenshot them. Yeah. And you can have them separate or in the report. Report has some, I think, constraints. So either in an appendix or separately, you can submit screenshots. Okay. So let me get started in terms of today's topics. So in terms of scheduling, we are actually midway through this course. And I know we have covered some topics, and I know some of these topics were new to many of you, and it's challenging, but the goal is not to be experts on these tools, but get an exposure of what is the tool for, how can I do the minimum thing, if I can play with the minimum thing. And you can. Some of the tools that we saw, Docker or serverless or Flask or web app type of thing, you can do something minimal. Okay, so that's why these topics were chosen. So I think you should get a sense of that at least. Okay, and if you have questions, do not hesitate to ask. I know some people ask, but many people are silent. Please ask questions. So as we said, there are a couple of lectures. So I'm trying to portion what we want to cover into those two lectures, including today. With that, actually, let me. But I will talk about the project logistics as in the presentation logistics right before. I mean, 1 week before the presentations are going to happen. So today, actually, we're going to switch topics. Instead of model deployment, which was what most people think of model deployment as the scope of this course. It's not. Model deployment, as in like project, serving the model on a server anywhere, is just one component of this, of this course. So today we'll actually pick up on the second bucket of things, and in fact, we'll just play with versioning mostly today to keep it within time. And if we have time, obviously we can do scheduling and other things. Okay, so I'll discuss these when I get there. But so today's subject is model lifecycle management, some aspects of model lifecycle management. In particular, we are looking at versioning. So that's the scope. Any questions here? So the other topics we'll cover in the next couple of lectures. Okay. And last time we also covered Git, and today the reason we covered Git last time is today we want to try some more things in Git which are related to versioning. At least one of the tools is related to versioning, so we want to get a sense of Git. So how many of you have not yet created a GitHub account? You should try it. It's free. So you should GitHub, or there are many other vendors, but you can create a GitHub account and get started. At least get your figure out in case if you want to use username password, you don't have to put an SSH key in there. But if you don't want to use username password, then you need to submit an SSH key into that system. We have not seen SSH key generation in this course yet, but we did use the SSH key pair when Amazon EC2 machine was used. The .pem file or the whatever PPK file. That's essentially like the key pair. It's just that Amazon, keeps the one part of the key on the machine that you instantiate already. So you only get actually, the public key is already there in the machine, and your private key, the .pem file, which you should safeguard, is what you would download. Okay, so so as I said, we'll start talking about a few aspects of model management, and in particular, we'll pretty much focus on versioning today, and then get back to recurring jobs and scheduling, and even A/B testing later. Okay, so yeah, so versioning is a pretty natural idea. So just like you version control Google Docs, version control code, here we want to version control models and maybe even data. Okay? So it's exactly the same as the others for in terms of rationale of why you want to version control. And there are many tools here. I didn't list all of them, but MLflow is what we will go over today. Weights and Biases is also another probably $1 billion+ company, which focuses on model management, and in particular version controlling and logging model diagnostics. Okay. So what does this tool do, right? So the tool has many moving parts. So we'll look at MLflow as an example tool and just get a sense of versioning. As I said, versioning, we know on one sentence what it is. It's just a way to log a version of a model that we train. So MLflow has many moving parts, but we will pretty much focus on one aspect of MLflow, which is model versioning. So MLflow has other things, other capabilities. We'll open the webpage and briefly discuss that, perhaps. So this picture is just showing several things. Firstly, the workflow. So let's focus on the center piece. So there's data scientists on the left side, and then deployment engineers on the right side. So data scientists are concerned with, staging models, as in like creating new models. Although they're calling it staging, just think of it as developing new models, and here's the new models that we can deploy, right? And so dev engineers are focused on, getting that model production, which is exactly the Docker stuff that we saw. Maybe that model is part of like 10 containers that are simultaneously serving and listening to requests, right? Or 100 containers. So that's something that they will enable. And also they need to kind of, archive models. Sometimes the models are no longer predictive anymore because people's behavior pattern changed or your data changed. In fact, data drift is one aspect that also has tooling around it to detect data drifts. So some models need to be archived. Okay, there's automation that you can build in to understand that your current model is not up to par, and you can actually archive it, right? And so how do you actually manage, in this picture, there are like 5 dots corresponding to 5 models. So the question is, you could have 5 models, you could have 500 models. How do you kind of properly manage them? Okay, these are all different versions, maybe trained on different data sets, trained at different points of time. The way you do it is similar to other things that you can also version, which MLflow calls them parameters, metrics, parameters and metrics, and then other things like metadata, artifacts, and models. So what are these things? These are all belong to the same category. They're not code. They basically are, for example, parameters are the parameters that we use to define a model, like, let's say the tree depth of if it's a decision tree, or the number of trees if it's a random forest, for example. Metrics are those numbers that you log when you print out, right? Loss on epoch 1, loss on epoch 2, loss on epoch 3. That's metrics. Artifacts are things like confusion matrices. Like maybe you plotted the confusion matrix using Matplotlib or SNS or something, and then you want to save it, right? It's a PNG file or an image. So that could be an artifact. Metadata is just some other information about your project or some experiment that you ran, and models are are what we've been talking about, right? So all these can be tracked using MLflow is the name of the technology, this technology by Databricks, but by its tracking server, okay? So the server is just like the web server that we've been looking at. This server lets you log these things from your program. Like you can talk to the server and say, hey, I generated this confusion matrix, take it. And so it'll take it, save it, and you can, go to a browser and ask for, show me the confusion matrix for an experiment that ran 2 hours ago or 2 days ago. It'll show you the same thing that you saved. Okay. So that's what the tracking server does. model registry is only focused on models. So model registry is like if you have trained 5 models or 500 models, you can keep you can say, okay, this is version 1, this is version 2, this is version 3, just like any other registry. Okay, remember there was a registry for images for Docker, so you can say, hey, Docker image built on in September, image built in August, and so on. So you can version these things. Okay. But model registry is for easy reference in case, okay, somebody wants to say, I want a model from 2 months ago because it seems to be, more useful than the current model, and you can easily reference and download it and run it. Okay? So that's about versioning. I think and in this figure, they're just showing the same thing. Model curation, which is the logging that we'll see in our example. Model registry is where you can refer back to older models. It's the same as UI, but we'll not spend much time there. And model serving, we have already covered it quite a bit for the past 2 or 3 lectures, so we'll probably not do it. But MLflow tool also does model serving for you, so at least at some level. And so you can say, okay, what is this tool for? I mean, let's focus on versioning, and the other things we'll see later. Okay?
So when you say serving, it means putting it on a server.
No, it actually is. It kind of does the same thing as what Flask and what you did with Flask, for example. So you can just say serve model XYZ, where model XYZ is some name that you gave in this, that's present in the registry. Then it'll just basically replace the role of Flask, for example, or replace the role of the serverless Lambda function or something you create. Yeah.
But can it be attached to other servers?
Yeah, so you're serving. So remember, the serving, you have to start this program server, and it's continuously running and listening, trying to listen to requests, right? As long as you connect it, expose the port. I mean, you have to say which port you're listening to, and as long as you expose the port, anybody can make a request. Yeah, just like the Flask app. Yeah. So let's actually, let me stop there. So there are only a couple of slides of versioning here. What, as I said, I've been saying is that we'll go to their page and just run through their getting started code or tutorial code. Okay. So for MLflow, we'll just do that, really focusing on what's happening with how do you track things, how do you version things which are not just the code itself. Okay. And actually, you'll see that the ideas are not complicated. Many of you have programmed in Python before. You would have used print statements at least, right? So print statements, hey, I finished part 1, I finished downloading the data, I finished training the model, or something like that, right? So it's just an evolution from prints to maybe proper what is called logging. So the Python standard library comes with a logging module, or you can also use third-party logging modules. Logging is a little bit more, I would say, standardized way to log, something like information versus a debug level information versus an error versus something else. Okay, so you can have different levels, and there's some standard structure you can follow, so that there are other tools that can consume these logs and can be reported on later. Okay, that's logging. So from prints to logging as in versioning our model in a potentially a remote location. Although we'll see it, we will do that locally here, but we can always log that model in a remote location. Not just a model, but the other 5 things that I mentioned, like parameters, metrics, artifacts, metadata, and models. Okay, so let's actually go through this tutorial. So it's on mlflow.org. So it's saying it'll do many things. We'll only focus on training. We'll only focus on the step 1. Okay, not so much the training part. We'll just do a regression training, but I just want to show you how MLflow is used and then how to go back to it later. Okay? This is actually a very good functionality because many times and many of your projects you will be training multiple times, and many of the times you might be getting subpar results or maybe errors and so on. All that is logged so that if you want to go back and check something, you can. Okay. So they have, I guess, both Python and R bindings, but we'll just install, we'll just follow this and install the Python version. Okay, so let's actually just do pip install. So I've already started Jupyter Lab from, I just started Jupyter Lab just before this class. So let me just create a new folder. Okay. Actually, that doesn't need that. So let's okay. So we'll just install MLflow. So this will be needed for both if you're serving. I mean, if you have a, so what we're going to do is we're installing MLflow on the client side. So if you are going to log something, you obviously need an MLflow package. If you want an MLflow tracking server, like something which is or serving a model, obviously MLflow also needs to be on that machine so that you can actually do that serving, or in our case, I guess, log the track stuff. So a lot of dependencies. So let's get that installed. Any questions of where we're heading now? So we are in the topic of versioning. We'll do MLflow first. And there's a couple of other tools that I wanted to talk about. I just want to quickly mention. We'll version models now. In the second demo, we'll version data using a tool called DVC, but it's fine. Any tool kind of, we'll see the pattern of data versioning. And then the last tool we'll see today is called CML, but it just stands for, I guess, continuous machine learning. So it relates to the idea of CI/CD. I think I mentioned this acronym CI and CD in lecture 1. CI stands for continuous integration. It's about every time you make a change to your code and let's say commit it or do a pull request, something gets triggered, which is some programs are listening to when a pull request is raised. For example, pull request or merge request. And those programs are going to run, for example, a battery of tests. Okay, like using PyTest, for example, right? So that is continuous. So you don't have to worry. You don't have to focus so much on testing manually. So every time you make a commit that you're happy with the feature, there's an automatic, test that get triggered. Regression tests, unit tests, integration tests, all sorts of tests. That obviously you have to write it, but once you write it, it gets automatically triggered so that you have a continuous integration, basically integration test, if you want, happening. In an event-driven way. Okay, so that's the last part. So let's go back to the tutorial. Sorry, not this one. So we installed MLflow, and so the model is actually inside this MLflow repository itself, which I think is pretty heavyweight, but that's fine. Wow, the whole repository is being downloaded, which is pretty inefficient, but okay. So let's look at this example, right? So this is just a very simple training script, but you can imagine the same thing happening with others. So MLflow has some extra nice functionality to work with third-party packages. Okay, third-party packages means things like scikit-learn or PyTorch and so on. But yeah, so the way you do it, so let's see here. So what's happening? So we have a logistic regression model and a very simple X, Y data set, right? And fit and score are functions that you would have seen from scikit-learn. So this is the pattern with which you fit and score the model. So here's the first instance of MLflow, right? So MLflow.log metric score, right? So this is logging the performance result, the score value. And next, we are making a bunch of predictions on the existing data. We are actually, there's a helper function called infer signature that is needed to log the model. Okay, log the model is basically save the model, just like saving the score for this model. It's also logging the model. Why is this needed? This is for, we'll see when we see the UI. This is not, this seems very elaborate. You could just, create a pickle file, for example, and also save it. But this is just a little bit convenient way to do it. Okay, and that's it. And that's the print that you have saved it somewhere. Okay. And we'll see that actually we'll save it locally for now. Yeah, any questions here? So this is a very simple script. So hopefully it should be.
So like logging the model, is it like use it as a function and like in the future something like that?
Yeah, so we are doing it in a in a non-standard way here, as in like MLflow specific way here, because we can also serve the model later. Okay, so if we just wanted to log the model, and if it was just a dictionary or a bunch of numbers, or in linear regression case, just coefficient and intercept or something, then you can just save it as two numbers, just like log metric. It would be some other log parameter or something. Okay, but here we are doing it in a little bit more elaborate way. Yeah.
So log would essentially give us the date and time snapshot of when the model was run last, right? And then log metric is what we are scoring, what we are using to store our predictions or the parameters.
Yeah, log metric is supposed to be the metrics of your training process, ideally. Log parameters you are not seeing here, but log parameter would be, it's a logistic regression model. The logistic regression model doesn't have parameters, but let's say you had the regularization coefficient, for example, or the number of trees I was talking about, or the tree depth. Those would be parameters. They're not the result of training. Actually, metric is also here a little bit. So let's see, I think, so I'll have to check the definition of score function, but if score is, generally log metric is used for a collection of numbers, like an array of numbers. So it makes sense for like logging loss values over training data or validation data or something.
Like so how are we saving the coefficients?
Yeah, that's what. So instead of directly saving the coefficients, we are doing it with a helper glue function. Okay. This helps with later on serving the model.
Okay. The log model is essentially helping us save the coefficient.
Yeah. Log model is actually logging the LR, this object, which is a scikit-learn object, right? It's not just, but it's just a collection of two numbers. Yeah.
Professor?
Yeah.
So how MLflow does the versioning is we have to write all our modeling code through it.
No, so every time, so if I run this twice, there's going to be two models that will be logged.
So I'm just trying to understand, like in a real time scenario, suppose I've designed two models and I have to do versioning using MLflow.
Yeah.
So I would have to like change those codes to be able to use it through MLflow, like how you've done MLflow.
If you've already logged models before, is what you're asking?
If I've just designed two models.
Yeah, which means you already have created models.
Test this model now to keep the versioning of it through MLflow, right?
No, if you already pre-created models before getting onto MLflow, then you have to have some one-time script to kind of put them into MLflow first.
Yeah, so then I will have to convert those codes to an MLflow version, right?
I mean, this log model is just a fancy thing, but if you had a model, you can always save it as an artifact with no issues. So yeah, but you need a glue code to read the model and then save it like this. Yes.
Yeah. So I would have to be able to access those packages through MLflow.
Access packages. No, you can access the model. No. I mean, the scikit-learn thing is actually a helper. This is like a really bad tutorial example because the minimum requirement for, actually we should have seen the getting started instead of the tutorial. You don't need this, okay? So as long as you have MLflow import, you can log anything in any program. Actually, it's not even related to ML, right? So any program that you've written, you can log any text numeric value in log parameter, any array in log metric, and if you have artifact, there's a log underscore artifact, which is typically a dictionary or something which is not non-standard, like a pickle file or an image or something, you can just log them. So there's nothing, that would be a minimal example. These extra scikit-learn and input signature, just extra helpers for scikit-learn models so that we can use it later, but we're not gonna see that yet. We can comment that out if it's confusing you for now. We don't need them. Yeah. So if you have pre-trained, if you've developed models before, you will have to push them into MLflow. Yeah, if you have a model, but if it's a model that you already have created, like a bunch of coefficients, if you want some nice functionality, you'll have to do it this way. But if you just want to, save it, you can just save it as a couple of numbers. If it's just, you can just save it in different ways. Let's come to that in a second. Let's actually at least version 1 model first. Then you'll see the, so there's a lot of moving parts to this MLflow. Firstly, logging, right? As I said, this is literally like print statements, except instead of print statements or logging statements, it's just MLflow.logx, log_x. But otherwise, nothing else is happening in your code. Okay. Let's actually follow the tutorial and stuff, jumping ahead. So actually, this is not the model, right? Oh, this is saying do elastic net wine. Should we change? It's almost the same. It also has a logger. So this is what I was saying, right? So you evolve from print statements to something which is a little bit more formal, which is a logger, like from the Python standard library or a third-party logging. So anyway, we don't need this elaborate thing to show the minimum. So let's actually and let's ignore the other 2 files. They are demonstrating other capabilities of MLflow, but we just want to do the model versioning. That's our yeah. What's the name of that? Scale logistic regression. Oh. Okay. Okay, so what happened, right? So let's actually just refresh. So since we did not explicitly provide a tracking server, so tracking server would be exactly like the client server model, but the server would be somewhere else, okay, with some URL and port and all that. We didn't provide it. So by default, it just logs locally. So this folder, sorry, oh my God. So this folder actually, shows, it is just a directory with a bunch of files. So if you go in there, it gave an arbitrary name, experiment name, or a run number, sorry. And then it has exactly the things that we could log, right? So metrics, it logged the score, and yeah, it showed at some timestamp, some number happened. Okay, that's what it is. And we'll actually see it in a more interesting way in a second. And same thing with, I don't think we logged any parameters. Yeah, we did not. But you could do log_parameter with some parameters for the for your data set size and things of that nature if you want. Okay, so this tutorial is actually doing a little bit more. And then MLflow UI is a nice handy utility to see the same thing and see the log things through a browser. So let's do that. So you should do that in the same folder that you have the examples, or wherever we had the runs folder. Okay, ML runs folder. It's basically like a Flask app, actually. So yeah, I've zoomed out a little bit, but if you had a local folder, right? So in that folder, ML runs and 0. So 0, I guess, just corresponds to the default experiment. They have like a 2-level categorization. So there's an experiment, like let's say you're running logic regression models. Let's call that an experiment bucket. And within that, all the variations you're trying out with logic regression could be different runs. So here's the first run that we ran. And if you click on it, then it shows, okay. It shows many things, but basically it's saying when was it run and how long it took. Sometimes finished, sometimes it errored out, and you have the usual things here, like metrics that were saved. So here's the score metric. Okay, generally you score, as I said, it's an array of numbers as a function of time generally, but here it's just one number. So this is what you see, and so that's on the experiments tab. On the models tab, there is no model. Oh, okay, let me actually come back to experiments. Oh, there's a model.pickle. What's it?
I think I need to register one.
Yeah. But the actual file is just stored as, looks like a pickle file. For scikit-learn, if you remember, I think most models are just stored as pickle files. Yeah. So, okay, we have to create a model. Okay. So that we registered the model. Now, if you run the training again, you will probably see one entry, or like you'll see versions. Okay. So anyway, this is absolutely bare minimum of tracking plus UI is fine. UI is actually useful for comparing. Like if you do it 10 times, there'll be 10 such runs, and you can actually compare across if you want. Okay. Any questions about this very minimal versioning that we did? We can do logging of other things in a second if that's useful. Let me see if there are other examples which are better. So if you see, there are actually a lot of different packages that it works with. LightGBM is another thing. If you've used LightGBM before in 572 or 575, and also it has many other I guess many other packages it also works with. So, but that's the extra glue for if you want to be like, if you don't want to write elaborate code and manage the modeling, model saving yourself, like an artifact. Let's actually see this one. Just want to show you if there is a log something else. Yeah, here you can see there's a little bit of difference between two function calls. Log parameters is like the parameters of your model, or parameters of your experiment, in generally speaking. And then metrics are something that you compute, but they could be time series. Okay. Any questions here? And you don't have to rely on log model. If you're doing some custom model and it's not one of the scikit-learns or PyTorches and TensorFlows, it's fine. You can still use this library for managing your models.
How do we run test?
Test
on this one.
Once
you registered the model, then obviously we need to run it on test cases.
Test cases, as in like it's like a test, as in like a Python, regular Python test.
Calculated the parameters.
Yeah.
All the coefficients, we need to use it on some unseen cases.
Yes.
How do we do that?
So this is just for logging, right? So that testing part could be something that we'll see as part of continuous integration. So continuous integration is this idea CI of CI/CD acronym is about testing, in general software testing. But for the ML case, you could call it. You could actually do unseen data test or whatever test data report numbers, right? You could do that, but that would be not just related to log, not just related to versioning, right? It's a little bit, the scope is different. Okay, so let's actually go to a slightly different topic, which is, you can version control data in multiple ways, but this is one tool that I wanted to show. It's called DVC, it's called data version control. It's like Git, and that's why last time we saw Git. We're gonna do this. We're not gonna, so just like the previous tutorial, we did not go through the whole tutorial, in fact. But here we'll just do how to version control data. Okay. So this is actually, I think, a little bit more heavyweight, but I'll reduce the number of epochs and whatever. There's some training that's needed so that we don't, consume time there. So what is the purpose, right? So just like we saw model versioning, in the same thing, we can actually also store data. Okay, if you have a pandas, so in case your data was just a data frame, pandas data frame, let's say if it's tabular data, right? Like which was the case in a regression example, we could just store the whole thing as a data frame, or actually create a CSV file and say, okay, save the CSV file as an artifact of this run. You could do that, okay? But that is inefficient because I mean, there may be other ways MLflow can deal with it, but if you're going to version control your data, you don't want to copy multiple copies of your data. Okay, so it's going to just be very expensive to keep on making copies of your data set. Okay, especially if it's, let's say, 1 GB or 10 GB in size, or even much higher, then you can't make copies, right? So DVC is a tool to kind of deal with that copying aspect. It's exactly version control. Version control, the whole point is not replicating the manual process of writing _v1 _v2 and actually making copies, right? So you for example, in code, in Git's case, Git only maintains the difference, right? That's why we could see the difference between what commit we made now versus what commit was there before, right? So that's efficient instead of making copies of the code all the time. And if you want to revert back, you can easily revert back. So here the same thing with data. So what is meant by version control of data? So let's say you have 1,000 images and you have class labels for them, and you trained a model, let's say a classification model, and now you have fetched, you've got another 1,000 images, then it's the same data set, almost, it's exactly the same, in terms of structure, except you have 1,000 new images, right? So are you gonna, how are you gonna merge these two, right? So you could have version which says, okay, I'm gonna version control this data because that was data used to generate model 1. And with this additional data, I'm going to rerun the training, and now it's model 2. Okay, so that you don't have to make data 2 copies of the first set of data. Okay, and you could do more complicated things, like maybe in the 1,000 image data that you had classes, and you found out that the class labels were not correct, right? Then you already trained version 1, and now you make improvements on your data quality, and that could literally be just changing the class labels, or maybe deleting some images, or maybe cleaning up the image. Maybe there's some artifacts, occlusion and stuff, and then you can just version control that change. Okay, that change is detected. Just like code, just like models, it's just a version control of the data. Okay, so DVC is a tool to just deal with this in a little bit efficient way. Okay, and in the large scheme of things. So let's just go through their example. I mean, we're doing a lot of Git clone from lecture 1, so I hope you can learn Git at least as a byproduct of this thing. Let's go here. I mean, let the UI run. This was not useful. Okay. Okay, so we cloned the repository. And they have a different set of requirements. So let's see if the requirements are heavyweight or not. So So one of the negatives of many of these code examples is that I have not included the requirements.txt file in each of the examples. Okay, so there is obviously scope to improve. This particular example needs these somewhat heavyweight packages, but I think we can install it. So look at README as well. Okay. So this is actually doing heavyweight training, and we're actually not going to do the whole thing. So we'll just run one epoch. I think the data set that we, the repository that we downloaded, we're going to get, we're just going to follow this tutorial, right? So this is just not related to our data version control, but there's just a cats versus dogs classifier using images. So, I mean, we don't have to follow this DVC get. I mean, if you have the data, you can just download it from somewhere. There is a conflict. Okay. So what we should do is actually I'll just create a virtual environment here. Wait, you can check which Python it is, and so anyway, and these arrows here means which versions you are willing to install. Greater than equal to 2, less than strictly less than 3, and TQDM has a strict requirement of greater than equal to something and less than. So ideally, if you're gonna work on any code, you should have these types of requirements. Okay. Okay. So we have the install. Did we get the data? We did not. Okay. Okay, DVC not found. Let's see what's the best way to install DVC, which I did not install. I'm using Linux, so I'll just, you can just pip install DVC basically. Right. They could have put that in requirements, but they did not. Let's see which a lot of dependencies because it does a lot of things. So 3.20.0. Right. So this is how you specify exactly the same version. So if I did perhaps pip install requirements, it should not error out. Okay. So anyway, now let's actually install, get the data. And so that's and then let's remove the data file. So the data folder is there now, and yeah, I mean, probably have this. So okay, so we have the data folder properly set up. Now, just like Git, this will just follow the same type of workflow. So here's the data, right? So we just opened one of the images, but this is how the data is, right? So data has 2 subfolders, train and validation, 2 subfolders for the 2 classes, and all the images related to it. So you take a snapshot of the first data, the current data, okay, before you make any changes. Data, DVC add data. So okay, let me do ls minus LA to just show you that this repository that we downloaded has these hidden folders, okay, .dvc and .git. Okay, if there is no .dvc, then you can create it by not explicitly creating a .dvc, but when you DVC init, just very, very similar to Git init. Okay, we're just not doing that here. So when you say add data, add folder name. In our case, the folder name is data. Okay. So it's saying that if you want to track changes with Git, run this. And if you want to enable auto staging, which we have not talked about, we'll not talk about staging today for this tool. We just want to version control data. You can run them. In fact, I think the tutorial suggests that we run it. But okay, we have added the data. We'll come back to it in a second, how to check out the version data, very similar to Git checking out. But if you do python train.py, if you have installed TensorFlow and all that, it should ideally train. I think I don't even want to train the whole thing. So let's see. Epox 1. Anything that I can reduce to reduce the time taken here? Yeah, I don't think let's see how much time it takes. I mean, this is TensorFlow specific, some logging that's being generated.
So what happened the first time when we did not specify a version number for DVC in the requirement section?
Oh, I did not add DVC directly in the requirements. So I wrote it, but I didn't run pip install from requirements. I could have, but I did not.
But if you do not put in a version number, does it take the
latest version? Yeah. I think this probably is going to take some time. Yeah. So basically after this, you get a model.hpy file. So that's, this is very similar to pickle file. You can again add that to DVC if that is a large thing and you don't want to save it in version control, because you don't want to save it in code version control, which is Git. Okay. So here's the command I think that was also suggested when we first ran add. So it's saying if you want to track the data version that you used with the code as well, then you add whatever the file name was, the file name .dvc to your coding version control, in which case the coding version control is just going to track these files and not the full data set and not the full model file. It's just this extra file that we have is has an extra extension called .dvc. It's not the original, it's not the data, it's not the model itself. It's a link to those two things, because those two things will be managed by DVC. Okay. You may say, okay, why do I need this extra complexity? I can do this with Git itself. Okay, you can just log the model and log the data with Git, but that's a bad idea. Git will not work with really huge number, huge volume files, okay, large files. Okay, so here we're just tracking those references to them, and some extra small files, some output files from training, and I'm just logging it. Okay, so and you can see that yeah, you should see the .dvc file, the metrics, the actual model file here. You'll get the model.hpy.dvc when you add DVC, add the model name. Okay, let's just do DVC, and so now we have that. So now we can actually do that commit that was being shown in the tutorial. So we have all these files. We can just add all these. So this is exactly the idea that we saw last time. You can add a file, which is like staged, and then you can commit that staged thing. Staging just means ready to be committed, ready to be versioned with a potentially a message with it. So for example, if you say git status, it says nothing staged, these things were modified, and these are not at all being tracked. Okay, that's fine. Those could be extra files that you don't want to track, then you can ignore them. But what we want to do now is track these two. Not just these three, but like a couple of more files. So metrics, .git ignore, and data and model. So let me briefly mention so .git ignore is a file that Git reads and says, okay, maybe I should not track these files. Okay, that's the idea. So it's not going to track the data folder, the model HPy file, and we don't have a .env. Actually, what we have is venv that we can. So now if we look at Git status, it's still tracking some extra things that we don't care about. So we can actually edit git ignore and say, okay, okay, now when you so now it says we modified git ignore, ready to be committed, and these three more files. We have made changes to git ignore. We have made changes to git ignore, requirements for text, and train. Why is it saying two things are modified? Modified as well as studied. Okay. And then two extra files. Okay, let's ignore those files. So I can add requirements, and I can add train. So I just am carefully like trying to figure out like which files. I don't know why there's a modified and ready to be committed for. It should not be two, but anyway, so now all these files are ready to be committed in checkpoint. Okay, on the code side, we're not committing the data or the model itself. Okay, just the references to them. So in fact, let's see what this has. See, this is just a text file, and same thing with the .dvc, the other one. It's just showing some tracking information that DVC tool understands so that it can retrieve the model and the data. In fact, if you don't specify, the DVC tool saves them under some hidden folder called .dvc in your home folder, which is, you'll have to read the documentation to see where it saves. But for example, next time I make changes to the data, let's say instead of this data folder, I have some more data, then that's the new data folder, right? So the old data folder is still, some efficient version of it is still saved in the .dvc folder somewhere else. Okay. So let me close this. Come back here. Okay, so we checked it in. Let's make commit as well. Maybe no need for tagging. Okay, let's ignore the tagging part and these files we didn't. So these are NumPy files. I guess we don't focus on them. Okay, so now let's get the second set of data. Okay, we got the second set of data. A zip file we can delete. So apparently now we have 2,000 images for training and 800 for validation. So now, so previously we had 1,000 images for training and 800 for validation. Now we've doubled it. So the way we do it is, again, repeat the process that we did for the first time. So we again add data. So when we unzipped it, it actually unzipped into the data folder itself. So the data, you should be careful doing this, because if you had some same file names, it would have overwritten. Anyway, so you add the data, train again, and you can add the data, add the model. So these are new ones. And save it. So that's what's happening here. I will not redo that, but that's what we did here. Now you can actually just go back. So now what happened, right? So now you're in stage where you have the 2,000 example data set and a new model. Now you want to say, okay, I want to go back to the 1,000 situation, okay, in terms of my training environment. How do you do that? You just do checkout of the previous, whenever you train, if the model did not change or the training script did not change, then you can leave it as is. Then you don't have to do the first checkout. And second thing, you can, if you want to come back to the original data, you can do a DVC checkout. I think there is something missing here. Yeah. If you want to go back to the previous dataset version, we can check out like this. That's about it. So you can just increment your code versioning and increment your data and go back appropriately. So here, I think, yeah. So what's happening here is, how do we go back to the older data set is when you do git checkout, here it's version 1.0 only because it has been tagged that way. But if you git checkout a particular commit number, yeah, you can specify in that commit number which file you want to check out. Okay. So the first time you logged it, you had a data.dvc, which was referring to the 1,000 example. You're checking only that one out. And now if you say DVC checkout with this name, because that original file name corresponded to 1,000 example situation, it's going to get you the 1,000 example. That's how the mechanism is working here. But that's very specific details to this tool. All I'm saying is, this is one way you can instrument data version control as well. And this makes sense for situations where there is an iterative loop between the data scientists and annotators and data quality team, where data is not the fixed thing, unlike in Kaggle or elsewhere, where data is kind of ground truth and it's not to be disturbed, and we just focus on model building. Okay. Any questions about this? I know it's a little bit laborious, but it's good to understand these principles, and you don't have to use the same tools like DVC or Git. I want to do one last demo. It's an easier demo actually, and it's actually more interesting and useful, I think, is the CML tool. Okay, CML is again by the same company, but it gives you a flavor of how to get continuous integration for machine learning. Okay, so continuous integration means, and we'll follow the Git workflow, which means that continuous integration, one incarnation of continuous integration in Git workflow is when we made a commit. Remember last time we made commits and pull requests. We just want some tool to monitor the pull request, and when the pull request happens, trigger these tests or some downstream thing that you want to happen. Okay, CML is a tool for doing that downstream thing. Okay, so in this case, the example that we're going to run, it's actually going to, every time we make a commit, the commit is going to be some train.py type of a file. Every time we're going to make a commit, it's actually going to run Python space train.py and generate, let's say, confusion matrix and report it to you. So you're completely offloading even the training of your model and just focusing on the code, which is related to training. Okay, that's this example, but that's not the only way you can do it. You can, for example, as he said, once you create a new model, and you can commit perhaps the model with the Git itself, then some downstream, the continuous integration, what you can take is take the model, take some test data, evaluate it, and report a score back to somewhere. Okay, it could be an alerting system, or it could be just on GitHub, and we'll see this. This is just going to report on GitHub itself. Okay, so for that, we're going to just follow this this repository. Yeah, let's actually do it cleanly. So we're going to just use this repository called example_CML. I mean, if you look at the repository, it's not doing anything. It's exactly, there's another train.py. In fact, if you open it up, it's just a random forest classifier being fit on some, there's some data and you're fitting a random forest classifier. Okay, so that's all this this script is. Okay, just to kind of show you what it does. So let's actually, so for this, we actually need GitHub as well, because GitHub is what we're going to use to run this integration part. But GitHub is not the only vendor here. There are other vendors who can do the continuous integration for you. So let's actually clone this repository. So I'm going to do it in a little bit different from their example. So for that, what I'm going to do it is exit from that repository, from the repository MLOps code examples, which is our repository, and create a new repository. Okay, because I want to create branches of this repository. So anyway, for simplicity, let me actually open a different, this Python environment is different. So we're seeing 3 different tools. So I want to keep 3 different terminals. Okay, so I'm going to just git clone this example_CML repository. Okay, so let me just call this. I mean, I'm just going to rename it as CML_example. Okay, so now what I'm going to do is, okay, we can look at requirements. There's scikit-learn, there's something called setup tools, some basic module, and then matplotlib. So we can just install it. So this is the virtual environment that I created in lecture 1. So it's just, yeah, I'm putting everything in the same virtual environment, but that's for just instruction purposes. Okay, so what I'm going to do first is I want to do this on my, I'm going to create a new repository. Okay. So let's call this CML demo folder. I mean, you can call it whatever you want. So let me make a new repository. Just defaults. I'll just create this repository. Okay. And then I'll go back to my my terminals where I have this. Just to keep it this thing self-contained and not tied to that other repository from which we cloned. I'm going to do git. I'm going to delete the links. Remember, when we clone, it remembers where you cloned it from, so that if you have to push it back, push back the original code, you can push it back to the original location potentially. So I'm going to delete, not delete, but I think it's called remove. Okay. What I'm trying to do here is to connect this thing code that I downloaded to my repository that I just created in Git. Okay. So the way you add it is like this. Okay. So what happened? So we are on one of the branches, right? There's one branch here. And what we want to do is create another branch so that we can make a pull request into this branch, okay, into master branch. And when we do that pull request, the test, something needs to get triggered. Okay, so that this in this example's case, what will get triggered is the training of the model. Okay, so the model is actually so in this example it's training, but instead it could have done validation. But we're just going to trigger Python train.py. And there's no code here yet to do that triggering. Okay, so right now this code base is exactly like one of our Flask regression examples or something like that, right? So there's nothing going on. It's just import a few things, read the data from the local data folder, and do something. Okay, so what we'll do is git checkout is what we saw last time as well. Git checkout -b. I guess let's call it improvement. I'm creating a new branch now locally. Okay, this branch is not tied to the remote location. In fact, let me. So right now this is still empty. Okay, nothing is connected to this. Git checkout. It's called. Okay. This is how we switch master. Switch different branches. Git push. And you can say, okay, push to this remote location, whose nickname essentially is origin, okay, by default. This branch called master. Okay, so let's push that. And you can also push, what is it called? Improvement. Okay. So we pushed both. Oops, sorry, where is it? And both, you saw that the second push seemed like quicker is because they both are corresponding to the same node. So there's no new data that happened. And so although they're two branches, they actually refer to the same commit, same number. Okay. So here we are. So if I now, there's nothing to, okay, let's try. Two things are the same. So you'll not be able to open a pull request perhaps. Let's see. Okay, so there's nothing to compare because both the branches are the same. Okay, now we'll make a change, but since we didn't add the CML code, there's nothing. We can make a pull request and we can merge it, but nothing's gonna get triggered. Okay, I don't want to show that because right now there is no code to do that CML part. So let's go back to. Okay, so this is the important part. I mean, this has both it's using CML and it's also using a feature of GitHub, the vendor, called GitHub Actions. Okay, so you have to somehow trigger something, some job, downstream job to run something, right? So here we are running the downstream job, and you can see actually what is the job that we're running, and I guess in this case, GitHub is providing the compute services and as well as the glue services, everything needed to run this, which is pip install the dependencies and Python train.py. Instead of Python train.py, it could be, Python or PyTest, test fixtures, certain types of tests, or it could be Python, test or eval or whatever validation stuff. Okay, so we'll sorry. So we'll do a couple of things. Firstly, improvement is the same as is the same as the master, so there's nothing going to change. Let's actually check which branch we are in. I'm trying to remember whether I should have had the previous. Okay, we'll see how this works. So let's go to we need to change something. Let's say, okay, instead of depth 2, we'll make depth 4. Okay, just the tree depth of this max depth of the random forest classifier. Okay, and what we'll also do is create a folder called GitHub, okay, .github. In this, we want to create a folder called .github and call it workflows. Actually, you can't do it like that. So -p is the path. Okay. So we created a .github directory and a workflows folder, and let's go into that. And here you need to create that text file that we copied. Okay, so I think it's called CML. YAML is yet another markup language. It's just a text file. Okay. So this is the same text file from the browser, so from the tutorial, right? So, we're not going to parse this. It's basically saying on push, it's saying train and report runs on some, this is actually container, actually. And where is the container from? The container is from that company's, which has a CML package in there. And then these steps are actually specific to GitHub Actions, so we'll not pass them, each one of them, but basically what steps need to happen once a pull request is issued. Okay, so check out and then run. So if you see, there are actually a couple of changes. So I'm gonna git add GitHub, so that, and then git add train. Message improvement of model. Okay. And then git push origin to, I don't know if the branch name is improvement, but it is. Okay. Okay, so we pushed it. Actually, I think I should have added this GitHub workflow thing on the master branch as well, but let's see how that works. Okay, so now actually it says that there's some extra workflow which we just added, and then it says, okay, depth changed, right? So what we also need to do is, so you'll see that in our script, there was it says save the, okay, let me just go back to that. It's basically, there is a writing part of this, which requires a special permission, extra permission, writing permissions that GitHub by default doesn't give. So what we do is go to settings. I mean, this is just a one-time thing, but you go to settings, go to actions, go to general, and say, you can give write permissions basically. By default, it'll be read permissions, but okay. So now let's go back to pull requests. It just suggested, okay, you have made a new branch and there's some change, so go ahead. But you could do it manually as well, right? And then some commit message, and then create pull request. Okay, something failed. Okay. I thought I changed the. So sorry, we just jumped into an interface which is related to actions. It's just showing the steps that it'll take because we submitted the pull request. The first time it failed, but I think it was because of read write permission. I thought I changed it beforehand, but so this is what happened. I issued a pull request. This is what should happen automatically. Any questions about this part? I mean, we are doing the extremely minimal working example, so it seems like, okay, why are we putting so much effort here? But this is what would be like if you wanted to do automatic test scores or automatic something to trigger once you train or once you fetch data or something like that. There seems to be some delay here. Okay, I'll keep this on, but I think once it finishes, it should show that, yeah, you finished it. In fact, I might have another example anyway. So let me. I don't know which one I did. Let's call this. Okay. Okay, I don't have the. Let me find the repository. So this is the previous run of this thing. And so yeah, you go to the pull request. So this is just same experiment basically. 1 second. Oh, actually, you should. Is this finished? Oh, I think this anyway finished, so I don't need to look at the other one. So this is what we were waiting on, and it finished. And if you go back to code and look at the most recent commit, it's not showing yet. Let's see. Oh. Okay, so I think it's, sorry, I mean, this is just a very hard way to navigate to this page. But basically on the commit, there's a, this is a different example, but it's the same example I just did before the class. But it's just showing what the bot should be writing. Okay, it should be doing the training, and then it's just reporting back the confusion matrix. Okay, instead of confusion matrix, it could have other things, but it should come up in that commit at some point, but it's not there. But anyway, any questions? Yeah.
I think I missed it, but how do you describe job with the big position?
We created a folder called .github and workflows and added and we are using GitHub Actions CI environment to do this. Yeah.
Master repository and improvement, that was our code, right? So you push a new branch into the origin. You added a new branch.
Yeah, when I showed the demo, I think I forgot to add GitHub workflows to the master branch. Oh, actually, let me just double check that. Yeah, actually, this is correct. So yeah, tell me, what's your question?
The job that the execution of the job is.
Yeah, yeah.
How did that get triggered?
Because of the pull request.
Because you pushed the master.
No, I created okay, let me not confuse with two different repositories, but this was the repository that created a few minutes ago, right? It had the master branch, and we created the second branch. The second branch has, we added the GitHub/workflow/ that text file, which specified what steps the CI job should be happening in the job. And then we made a pull request. Oh, actually it shows here instead of me digging around where the answer was. So when we made the pull request, before merging the pull, because it says in the text file, it only says on push, but it's not really on push. Actually, once you open pull request, it should trigger that job. And once once you're satisfied, then you can merge the pull request. It's not the Git tool, and we are doing more than the Git tool. This is not related to the Git tool itself. It's once we make a push to this vendor, the vendor is reading that file, extra.github/workflows. In any file, you can give any name, but CML.yaml. The YAML file is saying, okay, hey, on push, you need to do these steps. But it's not really on push. It's actually really on when you open a pull request. Okay. You open the pull request, this is where it shows, okay, once you're happy with it, you say merge. Okay. So what's the difference, right? You can look at what changed. The files changed, a couple of files changed, we added, obviously. This is not gonna look, this is just one-time thing. You'll not see the YAML file. This is where the CI instructions are. CI is continuous integration, right? And the only thing that changed is the depth. Okay. This is a check. Sorry, it's actually probably on push. No, on opening a pull request, there's a check that happens, which is what the CI job is. So it just opens, reads that there is a workflow or GitHub Actions file and does those actions. And then one of the last actions is to write one of the, before it closes everything, is to write that information to the conversation or to the pull request. Okay, and that's why it's writing it here.
I use Jenkins.
Yeah.
I was just trying to relate. There we would actually create jobs and we would
using a UI.
Yeah, like it would be like a server link.
Yeah.
I was trying to.
This is repository specific, right? In this repository, we have a file which says on push, or basically on pull, creating a pull request, run this job. Right. So every time if I change it now, then read up to 10 and rerun, recommit and then push it, the branch push will not trigger this. But once with that, if I say, okay, again, now open a new pull request, then it just immediately gets triggered. It's watching the event open pull request, basically, if you want to. Yeah. So Jenkins, which is another vendor, will have a slightly different way to do the same. And same thing with GitLab also. And same thing with other vendors. Yeah. Okay. So I'll pause it here. Actually, it took more time than expected, but let me. Yeah. Any questions about these three demos? Basically, I wanted to put them together because they're all related to versioning. One was model versioning, MLflow. The other tool was just data versioning, but the ideas are important. It need not be the exact tools, but they all kind of do the same thing. DVC was the second tool, which is just data versioning. And the last part is when you're anyway versioning, if you want to automatically trigger something, which is kind of related to continuous integration, you could use something like CML, or you can use GitHub Actions without even CML. Okay, the tool which lets you do it in a neat way, or report these confusion matrices and stuff like that. Instead, you could actually just use GitHub Actions, but you have to kind of say exactly what steps needs to happen. Yeah. Okay. Let me stop there. Any questions about these three demos? Not these specific tools, right? So I'm not, so the DVC and CML, I don't know. MLflow is, I think, is pretty reasonably used. I mean, there are competitors to all these tools. Like MLflow has a huge competitor, which is weights and biases, which is a proprietary. I mean, weights and biases also has actually a local. You can just pip install weights and biases and actually do almost the same that I showed with MLflow. They have a little bit different feature set. So, but yeah, I wouldn't say they are kind of obscure, but they're also, I don't think they're like the dominant, perhaps. I'm not sure. Yeah. Yeah, the model versioning, every company in the AI space, which is providing ML tools, ML related tools, will have a solution for versioning. Even SageMaker, for example, right? It has, tools for versioning. So every vendor is trying to kind of corner that we can do, X, Y, and Z. So
this kind of architecture then.
The patterns of like versioning data, versioning models. Yeah, you can expect that. The MLflow that we saw, for example, the one we did, there's no authorization or authentication aspect. But if Databricks is going to provide it, then there's going to be role-based access, for example. And so Databricks is going to have it as part of its offerings, right? So, but if you work with Databricks, yeah, MLflow will be part of it. But if you don't work with Databricks and you use something else, then you'll have different experience, like just like Jenkins versus GitHub Actions.
Yeah. I hadn't picturized this kind of whole architecture, like it is there in software development. But
yeah, we are just doing the same thing in software development, but adapted to our ML workflows.
Interesting.
Yeah. Okay. So what we do in the remaining time is actually the onus is on you guys to do two things. One is obviously replicate my demos if possible, but the second thing is actually to form your teams, decide on a project, and if need be, discuss with me.
Just going for discuss on the project.
Yeah, 1 second. Oh. I have some issue with okay, what happened to my okay, maybe it did not work. Oh, okay, probably did. Stop.